Very nice. Well, welcome to the Cycle 25, session 4, June 19th. I'm lucky to have John, VE6EY. John, what are you here to talk about?
Well, I'm here to talk about something I call spatial filtering. And this all started a few months ago. I was visiting a ham in Calgary. His name was Peter, VE6KK. And I happened to notice on the floor of his shack, he had a, I'm just trying to talk and set up my sharing at the same time. On the floor of his shack, he had a DX Engineering NCC1. And I got really excited because I've never been able to afford one of those, even in theory. Am I sharing okay?
You are. It looks good.
Okay. So then Peter said to me, well, I have an MFJ 1026 lying around somewhere as well. So I decided I'd borrow them and combine them with my ANC4 and my home-built X-Phase and do a shootout of spatial interference filtering, comparing how these 4 devices worked. And so you can see them here in the shack. At the very top is my X-Phase, which is inside a home-built plastic box that I printed. And the X-Phase costs $21 US in kit form. It's got a few transistors and a few, it's a very, very simple circuit, but it does work. Then the MFJ 1026 and lower down the ANC4, which are both around $230. These are marketed as noise cancelers or QRM eliminators, called many different things. And then finally, the NCC1, which was the previous version. The new version sells at around $900. These are all US prices. So in summary, all of these work. All work with some limitations. Only the NCC is a true phaser. But let me tell you, whichever device you select, it's the installation and use of auxiliary antennas or noise probes that makes the biggest difference, more than the device itself. So what you're looking at is my setup in the shack here. On the right at the bottom is a home-built switch, so I can switch between multiple noise probes and feed them in different directions. And then my main antennas come into the shack through a remote coax switch. So today we'll do terminology, the RFI environment we live in, spatial interference filtering theory. I'll give you some demonstrations using video of how well these things perform. And then we'll wrap up talking about noise probe antennas. Okay, so these things are typically called QRM eliminators or noise cancelers. I think that's pretty poor terminology, actually. These don't really cancel noise. They can reduce or cancel interference. So that's really what they are. And you can compare these to phasing or beam forming. You can compare it to diversity reception. I call all of these techniques SIFT, or spatial interference filtering techniques. And so that's the term I'll be using. So you can do SIFT analog or digital. What I'm talking about today is analog SIFT, where you have an outboard device that manipulates basically phase reverses and combines the signals from 2 antennas before the receiver. Or you can use diversity reception with 2 coherent channels of IQ signals at baseband, and you do some math on them and you accomplish the same thing. And examples of that are the RSP Duo and the ephedra or ANAN radios. Any radio that has 2 coherent receivers. So RFI environment. In case you're wondering, that's Jerry V6, I think it's TL is his call. That's his house and antenna up there on the right. The bottom line is we live in a world that was never designed with RFI or radio frequency interference in mind. Nobody ever thought about this stuff when we built our homes, our neighborhoods, our consumer equipment. We have EMI standards, but they really weren't designed with sensitive ham or SWL receivers in mind. So for example, if you actually go and take a look at the standards, you'll find that interference of S6 is within the standard. So that doesn't help you very much. We live in a world where public policy is focused on reduced power consumption, not RFI. So this has resulted in literally millions, if not tens of millions, of unintentional emitters called switch mode power supplies. We can talk about how they work some other time, but let's just say that unless they're properly bypassed and filtered, they're almost as evil as spark transmitters. Once conducted RFI couples into household wiring, your house turns into a very good unintentional antenna. So we all live in RFI antennas, surrounded by RFI antennas. So if you can't eliminate RFI at the source, you have to look at spatial interference filtering. And obviously, anytime you can eliminate it at the source, that's best, but a lot of times we just can't do that. How does RFI travel? Well, basically, it's got 4 paths. The basic paths are radiated and conducted. But radiated can be picked up and then conducted, and conducted can be picked up by, say, household wiring and then radiated. So you really have 4 paths. Spatial interference filtering works with radiated paths. So that's number 1 and 3 in the graph. Chokes and filters are what you want to use on conducted paths. You also need to consider the different kind of sources that work at different frequencies. At low frequencies, your AC sparks rectifiers, mainly conducted interference. At very high frequencies, HF and VHF, it's digital. And in the middle are switch mode power supplies, which are a combination of square and non-sine waves. They basically are the ones that we have to fight the most when we're working on HF. So they say necessity is a mother of invention. So about 7 years ago, a new noise showed up at my house. I turned the radio on one day, and this is from 11 to 13 megahertz. You can see what my normal reception looked like, and you can see the new noise. And the first thing I did was call my power company because I thought my power pole nearby had started up again, and he told me no, the power line was fine. So I built a direction finding loop, and I tracked down to my neighbor's kitchen about 300 feet away. She just had it wired, poorly wired by an electrician that didn't know what he was doing. And the result is the power supply for these halogen lights was overloaded, goes crazy. 7 years later, it's still there. I keep waiting for it to break. But it gives you a combination of hash free running oscillators and 120 hertz modulation with tons of harmonics. So that's my world. And this also spreads out over 20 meters and 40 meters, but it's worst in this band here. So I had to figure out how to filter this thing. And anyway, so very quickly, if you want a signature of switch mode power supply, look at the graph on the right. If you take a lot of SMPS noise out of your receiver in AM mode and stick it through a spectrum analyzer, you'll get 120 hertz peaks. 120, 240, 360, 480. It just goes up. I've just printed the bottom end of the spectrum there. And that's the same kind of peaks you see from a power line noise as well. But without going into details, it's the 120 hertz repeating peaks that will give you an idea of switch mode power supply noise. Also in the lower right, you can see the difference between square waves and sine waves. So I did a SPICE simulation with a 100 kilohertz sine wave, which is shown in red. And typically the switch mode power supplies have free running oscillators running at around 100 kilohertz. They're going higher now, but you can see that if it's generating sine waves, you've got up to 100 megahertz of hash coming out of them. But the moment you look at square waves, which you find in switch mode power supplies, with something like a 1 nanosecond rise and fall, that's the green bar at the top. So you get hugely more RFI from square waves than you do from sine waves. Okay, so there's the environment we live in. Now, the theory of filtering and RFI reduction tools, basically there's 4 types of RFI we have to deal with, and we've got tools for 3 of them. So tones we can easily tackle with notch filters. They work on birdies. Uncorrelated white Gaussian noise, that's really what noise reduction is built for, and it works fairly well. The old noise blanker deals nicely with impulse noise, but when you get complex interference like I have, which is a combination of many kinds of emissions from switch mode power supplies or BDSL or PWM motor controllers, we have no tools in our receivers for that, and that's where spatial filtering comes in. So analog SIF, this is how the ANC and MFJ and these ones that I'm talking about today work. You have 2 antennas, your main antenna, which is a combination of signal and noise. I've got signal showing in red and noise or interference, let's call it interference, showing in black. You want to come up with an antenna that's basically a lousy antenna for the signal, but a good antenna for the interference or noise. And then you stick that into your box, you amplify or attenuate and phase shift, and then you get out mainly signal and reduce noise. So that's basically how these things work. And the idea is the same with digital in a coherent 2-channel receiver, except rather than external box, you're just manipulating the signals down at baseband with a matrix of weights to adjust amplitude and phase of each channel, and you can get the same effect. And that's what I use all the time with diversity reception. And basically the results are about the same. You can get more control if you're using digital. So I took the boxes to the lab, and I generated signals to both the noise antenna input and the main antenna input. Basically, I just ran these signals at 1, 5, 10, 15, 20 megahertz and split them so they were equal. I also did some attenuation so that one signal was louder than the other, which is more typical when you're using a main antenna versus a noise probe. And they all worked about the same. You can get typical nulls of 20 to 40 dB just by the 180-degree phase cancellation. Only the DX engineering box is a pure phaser. You can use that to do antenna phasing and all kinds of transmitting things, but it also works very well in interference reduction. The ANC4 doesn't contain a level adjustment for the main antenna. The rest of these do, and you can live without that, but it's useful. The MFJ and ANC both have medium wave filtering. Now, the nice thing about the ANC is you can jump or remove that, but for the MFJ, you actually have to modify the circuit. So you can't use the MFJ really below 3 megahertz. Adjustments are pretty touchy with all the devices except the NCC, but they are repeatable. The NCC is actually a lab instrument. I know why it's so pricey, but nevertheless, they all work. However, you do get some overload or IMD from strong signals in these devices if you don't want your gain control. But they all work. They all give you 20 to 40 dB in the lab. And you just have to fiddle with them. But I wanted to convince myself that all 4 of these boxes worked the way they were supposed to work in the lab before I actually started playing on the air. So here's a typical use case. We're sitting here looking at 40 meters, and in orange you can see a couple of ham signals. One of these is coming from the southeast, one is from the east, which is not surprising when you live in Calgary. Then we have noise coming from the west, which is a switch mode power supply, that's N1. We have a router birdie coming from the east, N2, and then we have broadband noise, which is omnidirectional. So when you have one of these noise sources sitting on top of a signal, that's when you want to do spatial filtering. And the challenge you have is with spatial filtering and 2 antennas, you can really only null out one interference source at a time. And so if you have one from the west and one from the east, you're probably not going to get both of them unless you're really lucky. Here's another typical use case. On the left, 20 meters, normal signals. There's a LED TV spike showing up. I happen to know that because it was in my shack. And then my neighbor's router showing up around 14 to 15. Those are typical signals interferences you'll try to get rid of. Switch modes, power supply, you can see the hash and the various frequencies from the free running oscillators on 7 megahertz there. So these are all the sources you want to target. Now, this graph is kind of busy, but this is that worst case 11 megahertz noise that I showed you earlier. And I tested all 4 devices using 2 vertical E-field probes, or vertical dipoles, spaced 100 feet apart, fed into the device under test, then to my Perseus receiver. On the left side, you can see the raw noise without any device switched in. It's basically an S6 or minus 100 dBm coming in. The spectrum display shows the various peaks from the free running oscillator, and the waterfall just shows pure garbage at the bottom. So then we test all 4 of the devices, ANC4, MFJ. They both gave us readable signals and reduced the noise down, or the interference down, to about 118 dBm. Surprisingly, the $20 X phase performed almost as well as the NCC1. That just blew me away. It brought the noise floor down to minus 128 dBm, and you can see the tons of signals that become readable compared to the graph you're looking at the left. So if anybody asks or says these devices don't work, then either their device is broken or they haven't hooked them up properly, because believe me, they do work even at the $21 X phase. Okay. I'm talking so much. Am I still live, Rod?
Oh, absolutely. No, this is really good, John.
Okay. So I thought I'd do a quick comparison of analog versus digital spatial interference filtering. So these are my 2 active loop antennas spaced 100 feet apart on that same terrible 11 megahertz interference. At the very top is sort of the raw noise and signals that I was getting out of my RSP Duo. And then I switched on diversity reception with the RSP Duo, and you can see the improvement there with the signals popping up and the interference coming down. And then I disconnected one of the loops, and I just fed the other loop on tuner 1 into the NCC1. So you can see with the NCC1, the signals come down a bit more, but the noise comes down even more. So either way it works, I'm getting a massive signal to noise improvement. And this is sort of my proof that both of these kind of work the same way. And I'll push for diversity reception because you can do a lot more with it other than noise reduction, but it's a very useful tool for that. Okay, so now I've got a 5-minute video demonstration. There's 5 parts in it. The first part starts out with my worst case neighbor's lights. Then I show you a minute of router birdies being canceled, and then a washing machine motor. My neighbor's washing machine has got these motors that are driven to the max by pulse width modulation, and each time his washing machine motor switches up and down, you can see the bands getting wiped out. And then complex interference on the ham bands and shortwave bands. So I now have to try and see if I can seamlessly move over to we actually did a dry run to make sure this would work, but I have to figure out now how to get back into. I'm having trouble finding my here we go. I have to stop sharing first.
Yeah, stop sharing.
Yeah.
And then when you start sharing, do you have to pass through audio?
Yeah, I've got them hooked up. Okay, here we go.
Good.
Sorry for the delay. Okay, so here's the 5 videos. I'll just let them run. That's my finger.
Asuntos Sociales y Ministro de Educación de la República Democrática Timor-Leste, Antonio de Conceizao, llegó a Cuba para complementar una visita oficial que se extenderá hasta el próximo día 15 de junio. La delegación timorense dialogará con autoridades de nuestro país, ocasión en la cual se fortalecerán más los vínculos de amistad, solidaridad y cooperación existentes entre ambas naciones.
Expertos de Cuba participan en el Foro Internacional de Seguimiento a la Cumbre Mundial de la Sociedad de la Información, que se tiene en la ciudad suiza de Ginebra hasta este viernes por convocatoria.
I got the noise level correct. They go zero Austin, right? Okay, Helen. George Zero, Echo Austin Alpha Mobile.
This is the router.
Echo Alpha 5.
Yep.
India, Kilo,
Okay.
Juliet.
Yeah, this is the birdies.
Got it.
UL. I'm located near the city of Valencia. You're 5 and 9 here, Helen. And I'm beaming towards North America at the moment. It's a nice signal. G0EA, sorry, EOA. VE5EY.
Here's the washing machine.
Yeah, it looks just like mine.
Yeah. Okay, here's a switch mode power supply in a neighbor's house on 20 meters. You can see the bands of interference across the bottom.
That loader tractor still there if it is not usable for anything? And why can't it be sold in a smaller skid steer that would clean out the barn and be purchased?
So K5, YV1 for your final. This is K Quest 12. Get out of here once you're done, my friend.
And this is the last one, the most dramatic one.
You can't get the rate and investing in the profitable process. So these are the kinds of competing situations at the moment. But the primary ban is what we have a point in mind. And also it's the fact that the Chinese investment in the domestic market is now rising. Interest rates are going up. So on
If you find anyone doubting that these things work, just just ask them to watch that last video. Okay, let's just go back to my slides. I've just got a couple more left. All of those, by the way, all of those videos were, there we go, were made using my main antenna, which was a beam on top of a 50-foot tower, and the noise antenna was just the simple antenna I'm going to show you next. Okay, I call these noise probes because they're really trying to just probe for noise, and we really don't want signals, right? So after experimenting with about 6 or 7 different configurations, I settled on using basically a 4 to 5 foot vertical dipole fed by RG6 coming back to the shack and switchable. And so there's a piece of number, I think it's number 18 wire, runs up inside that plastic tube just to keep it vertical. And then I've got the other half of the vertical dipole wire just sort of floating to the ground. And what I'm trying to do is pick up RFI, which is mostly, but not completely, vertically oriented, and it's E field, not magnetic. So I set these up actually. The one on the east is for my neighbor to the east. This is right at the edge of my property, and this house is mostly router birdies coming from this house. They had a plasma TV, but it broke, and it's been replaced, and it's it's fine now. Then on the west side is at the edge of my property is my noise probe for the halogen lights lady across the street. And then on the south side, my neighbor next door has that washing machine, and also he shifted to VDSL through our local telco, and that creates a bit of problem too. So that's my noise antenna setup. Just really simple, but it works great. From time to time, I'll also phase my magnetic loops against the tower, and that works well too. And if you look along that chain link fence there at the front of the house, you can't really see it, but the other loop in my phased array is at the front of the house, just down there. So unfortunately, all good things come to an end. I started getting nags to return the test units. I think they feared I was not going to give them back, but I did. And I'll tell you, any one of these toys will do the job. Just set up a good noise probe. You can see my setup here down at the bottom. I built a switch bay for my different SDRs, and that little box on the right is for my 2 loop antennas, and so on. So it's handy being able to shift things around when you're doing testing. But the main thing here is spatial filtering works, analog works, digital works. Fill your boots. Thank you.
Very good. Wow, I am super impressed, especially those videos. It really dramatically shows off those items. Any questions from the crew?
Yeah, this is Pat. I have a question. So, John, seems like you've seen a lot more noise than I have. I'm in a relatively quiet place, but I do have a signal that will pop up on my waterfall as a spike. It'll go over a couple of thousand kilohertz and then pop up as a spike, and it'll just move back and forth like this. Do you have any idea what that might be? It doesn't happen all the time.
So typically, for example, if you've ever studied your interference from your monitors in the shack, you'll see when you turn the power on the monitor, you'll see that same sort of thing you're seeing, where it'll come up and then the power supply noise will just move across the screen, and then normally it'll settle down. I suspect you've got something like that that's switching on and off and moving back and forth.
Okay. I'll take a look at that next time. Thank you.
Yeah. You know, I moved into a house that was at the north end of a street right next to a provincial park. I thought I was being really smart, moving into a neighborhood with underground power and no houses to the entire northern quadrant next to me. That lasted about 8 years, and then it started building up. And I think pretty well most people today, unless they've got very high antennas, which most people in the city don't, or are extremely lucky, are just living in an RFI environment that is a lot like mine.
Thanks, John.
And I have a question as well, if I may.
Please do.
First of all, thank you. Great presentation. I've got an ANC4 as well as the FJ. The other is out of my budget.
Me too. Me too.
I have seen with a rather crude noise probe that I've been using. I do see some of that effect. So now you've got me more excited about the noise probe specifically. So what else can you add to the noise probe build out specifically? Like you've got two, right? You probably don't have them phased or anything like that. They're just in two locations on your property. I've got one similar, like it is a dipole. It's just a random length. What would be an ideal length? Like, is there room for experimentation there, or maybe it's just placement? So I'm looking for advice on the noise probes.
Okay, so I tested, most of these manufacturers recommend something like a 6-foot dipole just outside the house, close to the house, in the bushes, whatever. That's useless. I tried long wires through a magnetic balun or a 9-to-1 impedance transformer. I tried big loops, small loops, and then I went back to the theory, and the theory basically says most of this stuff is vertically polarized E field. And I can actually prove that by switching my my magnetic loop array will actually operate in E field vertical dipole mode, and that's where the noise is. So my advice would be with ANC4 would be to disconnect the main antenna and just listen to the noise probe, right? And try different noise probes. Try what I did, vertically oriented 4 to 5 foot dipole. We don't care about impedance matching or any of that shit. And any of that stuff. And you actually want a lousy antenna, right? So with my noise probes, I can pick up a bit of medium wave stuff at night, and I can pick up a bit of stuff on 80 meters using them as an antenna. But basically, they're almost silent when they get above 10 megahertz. So silent for signals, but not silent for noise. So that's what I would suggest you do, and try the vertical placement as close to the noise source as you can, and focus on your worst noise sources. I mean, I know what my target is. She lives across the street, and if I don't take that one out, nothing else I do makes any, who cares, right? So that's the one I had to take out.
John?
Yep.
This is Frank, K4FMA. It's just a great presentation. I think I ran across you some years ago. Didn't you do some remote control software for the Drake R8?
Yeah, I have a software product called Ergo that's been on the market since 2000, actually. It still works, and I'm still selling.
Oh, absolutely. So that's where I've run across you. Great presentation. A little backstory on the 1026 from MFJ and then the NCC from DX Engineering. They were both designed by Tom Roush, W8JI, who had worked at Ameritron when Martin bought Ameritron to keep it from going under. The 1026 was what I'd call the first draft product. And I think there are two versions of that particular device. It involves the noise antenna port. And then I think Tom did the rest of it with Tim Duffy at DXE and kind of upgrade. I don't know about the ANC product, but the fellow over in Eastern Europe that does the phaser, the little cheap phaser, it has a great line of products. It's just a sole entrepreneur, and I'm not surprised at the great results that you achieved with that. He just does some great work, and as a number of entrepreneurs, have. So you've really enlightened us, and I just want to congratulate you on a great presentation.
Well, thanks. And I can't stress enough the ham spirit of experimenting, because I used to do a lot of business with Fred Osterman at Universal Radio. And when the ANC4 first came out, he's the one that triggered me on it and suggested I give it a try. I never learned to use it properly. and it sat in a box for like 10, 15 years until my neighborhood lighting came up. And that's when I took it out of the box. And I think most people don't actually put enough effort into getting these things to work, which is why you see so many posts online that these didn't work. No, you didn't work. The box works fine.
And a great parallel example of that is MFJ has a DSP box that I've likened, with Martin Jew sitting in the audience when I gave a little talk on it, to a Swiss Army knife. That thing will just do a lot of stuff. But on the other hand, the UK company BHI has more of an appliance on their DSP line. And so what many hams want in their use case is not a bunch of buttons and dials to push. They want to set and forget, and so it depends on your expectations.
Yeah.
By the same token, you've hit the nail on the head here, in my opinion. Most of the negative press on eHam on these devices are from folks who just want to turn it on, turn maybe one button, and it's going to solve all the problems. But I think your demonstration has helped show why you really need to have an understanding of the device, and just don't buy one of these and two of those, and hey, my life is simple again.
Yeah.
John, a question, if I may.
Yep.
You mentioned that the noise went away above 10 megahertz. Is that a result of the noise on the band, or the result of the antenna you're using?
What I said was the signals went away. So if I listen to my main antenna, the lady across the street is S6 to S7. I shouldn't say the lady, the house across the street is S6 to S7. If I listen to the noise probe, it's still S6 to S7. Okay, if I'm listening to a signal as opposed to the noise, it's the signal that is very diminished, but the noise stays, which is exactly what I want for the phase reversal. And I've actually got on YouTube, I built a GNU radio simulator for spatial filtering. And the GNU radio simulator basically takes an audio file that I recorded and then creates some noise or interference and mixes it together, and then shows you how you can balance the IQ and get the noise to disappear. And if you play around with that, you realize you can mix different strengths. So if you have a noise antenna that's picking up almost as much signal as your main antenna, whenever you try to phase it out, you're going to phase out the signal you want to hear as well as the noise. Any other questions? So I go away now?
John Vince Dion. So thank you. That's the presentation today is a tremendous summary of many of your other YouTubes, and it's a great starting point too. The noise antennas, the 4 or 5 foot tall things, are they effectively like a sleeve dipole inside? Do you have construction notes on these things?
Yeah, I think I've got some posts on my website. I'll just bring up a picture here again, if I can figure out how to quickly share screen. Boy, this isn't something you can do in your sleep, is it?
Not so much.
Okay.
But you're doing a great job, John. I really appreciate this. This is a rich meal of good information for anybody that's interested in it.
So this is just, I think it's 1/2-inch conduit, plastic conduit.
Okay. Okay.
And I just ran the wire through it. I 3D printed some caps to hold the wire in place, top and bottom. And then I 3D printed a antenna breakout box that you can see at the bottom, which basically gives you 2 screw terminals, one for the main vertical, one for the drooping other half, basically ground plane. And then you can see the RG6 coming into it.
Got it.
And the RG6, I mean, you've got all kinds of impedance mismatch here, but it doesn't matter. And then the RG6s come into my shack, and I can switch between these 3 probe antennas. Or if I want, I can actually put 2 of them through a combiner outside. So that's how I do that. You may also have noticed when the ANC4 kicks in, the signal levels drop about 6 dB. You get about 1 S unit of loss by using these devices in line with your receiver. So you have to live with that little bit of signal loss. I didn't notice any signal loss with the NCC. And the MFJ gives you a preamp you can kick in to bring the signal back up. But with these devices, you're really targeting signal to noise ratio, right? That's what matters. You don't care if your signal drops a bit as long as your interference drops a lot more. And if you have a receiver like the RSP Duo, or you're running Simon Brown's SDR console with some other receiver, they will give you an estimate of signal to noise ratio, and you can actually see the difference of maybe 10 to 20 dB signal to noise ratio when you kick these devices in and out.
Perfect. Thank you.
Is the drooping counterpoise inside the conduit or outside? And by the way, great presentation.
Yeah, it's just outside. This is definitely quick and dirty. I wouldn't publish a QST article on these noise probes, but they really do work. And
they love PVC pipe.
Yeah. I mean, basically try anything that works. And obviously, if the noise is loud enough or strong enough, if the interference is strong enough to be interfering with your reception from a neighbor 100, 200, 300 meters away, then it's going to be strong enough to be picked up by a noise probe, right? It's really that simple. So you don't need a great antenna. You don't, in fact, you defeat the whole purpose of what you're doing if you use, like, if you had a Foursquare and you were trying to use it to reduce noise and not reduce signals, you would be disappointed. You could get some improvement with the null pattern, but the main improvement with these boxes is not true phasing of antennas, it's phasing of interference. And that's the one thing to keep in mind.
John,
Very good.
Can I offer that? That was a great presentation, by the way, and I very much appreciate it. I had a noise issue here, and I'll make this short because it took us 6 months to find it. I had a ICOM 756, so I had a display, and I got the power line display, and it moved across, and it was S6 or 7. I called our local utility, and they were kind enough to send an inspector. He took one look at my scope, and he said, "Yep, you got power line noise. We'll go look for it." It took them months and months to get to it. Because it was inconsistent, and what we found eventually is the ground wire on the top of one of the poles had broken off, and in wind and rain it would arc, and on dry days you wouldn't hear it. And then one day it all went quiet. I jumped in the car, and it was 500 meters south of me on the far side of a main road. And as I pulled up and jumped out of the car, the guy at the top of the bucket truck looked down. He said, "You must be Mr. West." But they were really cooperative, and my noise fell. But you've got me thinking now that now that I've got rid of the big noise, I've been content because I got rid of the big noise. Maybe it's time I had a good look in the shack, and especially with the flex radio with the display, and start looking at just what is my real noise here, because that was just a great presentation. Thank you very much.
Okay, thanks, Peter. And I'll leave you with a philosophical thought. Since we switched to SDRs with spectrum displays, all of these interferences have become so much more noticeable. If I'm tuning my FT1000, I'll notice the interference when I tune across it. But if I'm looking at my flex display, I'm looking at a whole spectrum of noise. And so I think mentally we have to adjust that a lot of this noise that's there, we just never knew about it before because we didn't have the spectrum display. Maybe we were better off with that. I don't know.
Yeah, I think you're right. I think I should just go downstairs and fire up my TR4 Drake transceiver, the old tube one, and not worry about noise at all. If you can hear them, you can work them.
There you go. Hey, John, fantastic presentation. Where would we find your additional information, your additional YouTube videos, that sort of thing?
So if you do a YouTube search, VE6EY is what they're under. If you go to my website, play.fallows.ca, everything I showed you here today is in much more detail on the website. So all I've really done here is summarized a bunch of stuff from the last few years.
Well, this is fantastic. As I said, a very dense information, which is great for this format. Thank you so much for your time. With that, folks, I'm going to end the